Dear friends, today we'll be going ahead and looking into what is 8085 processor, what are the concepts that are associated with this processor, and when with this processor, how it has been practically being used in the real life scenario, and what is a pin diagram of 8085 processor, and so on. Now, what are the basic concepts with related to microprocessor? It has been classified into three types. One is called as microcomputer, microprocessor, and microcontroller. Microcomputer, it is a programmable machine, and there are basically two principal characteristics here. It responds to a specific set of instructions in a well-defined manner, and it can execute a predefined list of instructions. So it has the predefined list of instructions, means the instructions that have been stored into the firmware. And responding to the instruction means the instruction that the user gives. Now, what are the basic components of a microcomputer? It has CPU, it has input-output devices, that is keyboard, mouse, peripheral devices, and the memory, which can be a static memory and a dynamic memory. Now you have microprocessor. It is a programmable VLSI chip which is included onto the ALU. Now, programmable VLSI chip means very large scale integration chip which is present onto the ALU register. It consists of ALU, it consists of registers, it consists of the different control unit that are controlling the entire operation and the task. And what do you understand by microcontroller? It is a silicon chip which includes microprocessor, then it is linked with memory and I/O into the same package. Now, this is the block diagram of a microprocessor. The microprocessor is being connected to input devices, output devices, memory, RAM, and ROM. Now, input devices are being connected to microprocessor in a unidirectional way, whereas it is being connected to the memory in a bidirectional way with the help of a system bus. Now, what are the components of a microprocessor? We have seen registers, ALU, and the control unit. And what are the components of a microcontroller? It is memory, I/O, and the peripheral devices, which can be a converter, timer, or a CPU. So what do you understand by A to D converter? It is analog to digital signal converter. And then you have a timer, which is connected for the controlling of A to D converter, and then you have a serial I/O. Now, MPU, the full form of MPU is called as microprocessing unit, which becomes a part of your microcontroller. Now, how does a microprocessor works? To execute a program, the microprocessor reads each instruction from the memory, understands an instruction which we call as interpreted, and then execute and then perform it. Here, it performs three types of operation: fetch, decode, and execute. You fetch the instruction, you convert the instruction to the machine language, and then you decode it. This sequence is continued until all instructions are being performed. Now, the data that is written into the 8085 processor is in the form of the assembly language. So, first of all, let us understand what do you mean by the assembly language. Now, the data that is stored in the program is in the form of Munix, and it is written in the form of hexadecimal data. So hexadecimal data converts in the form of Munix. For example, the binary code of 00111100 is represented by 3CH in hexadecimal by INR A. Here INR A, that is increment. A stands for accumulator. This symbol suggests that operation of incrementing of the accumulator. Incrementing means increasing of the accumulator is by 1. Similarly, 1000 and then 4 times 0 is equivalent to 80H is represented as add B. Add stands for addition and B represents content in register B. This symbol suggests that addition of number in register B to the accumulator content and the result is stored in A. So microprocessor has 256 such bit pattern accounting to 74 different instructions for performing of various operations that are being linked to it. Now, first of all, let us understand what do you mean by assembly language. Assembly language, we have seen it requires mnemonics, it is written in hexadecimal. It is also considered to be a language for the processors. It is produced by compiling the source code from a high-level programming language like C, C++, but can also be written from scratch. Assembly code can be converted into machine code using an assembler. Now, what are the different features of 8085? So, first of all, let us understand how 8085 processor got generated. It was being made by Intel. It is an 8-bit processor and can execute 8 bits simultaneously. That is 2 raised to 3. It operates on plus 5 volt DC signal, that is direct current supply. It is designed for using NMOS technology. So first of all, let us understand what do you mean by NMOS technology. So what is the full form of NMOS? It is negative channel metal oxide semiconductor technology. It is a type of semiconductor that is negative charges, so the transistors are turned on and off by the movement of electrons. It has 6200 transistors on a single chip. It provides on-chip clock generator, hence it does not require external clock generator. So the clock is itself present onto the 8085 processor. It operates on 3 megahertz clock frequency. It consists of 8-bit multiplex addresses. These addresses can be of address bus, data bus, which can reduce the number of pins because it is operating as 8 bits. It has 16 address lines. Hence, it can address 2 raised to 16, 64K bits of memory. It generates 8-bit I/O addresses, hence it is called as 2 raised to 8. 256 I/O ports that can be generated. It has 5 hardware interrupts: trap, reset 6.5, RST 5.5, RST 4.5, and interrupt INTR. It provides DMA, that is direct memory access. Now, why hardwire interrupts? Because if there are some unconditional errors, unconditional risks which are associated, so you require the interrupt to come into picture. So 8085 architecture mainly consists of a register array. It has ALU and the logical group, instruction decoder, machine encoder, timing and control. It has interrupt control group. It has serial input IO control group. So what do you understand by register control array? It consists of series of register which can be operated simultaneously. ALU, it is the arithmetic and logical unit which can be encoded simultaneously. Then you have the instruction decoder and the machine encoder. The instructions will get decoded and simultaneously these things will be getting encoded. And you have the interrupt control group and the serial input IO control group. Now this is how the architecture of a 8085 processor looks like. Now, first of all, let us understand what are the components of it. It has an interrupt cycle and it has a serial IO. What are the signals in the interrupt cycle? As we have seen, it has an interrupt, then it has RST 5.5, 6.5, and these signals are bidirectional. Then it is connected with the serial IO controller which is present in a bidirectional form to the 8-bit internal buses, which is called as SID, that is serial in data and serial out data. Then it has been connected to a accumulator. Now, accumulator, temporary register, flip-flop, instruction registers. Then you have a stack pointer, program counter, increment or decrement address latches. Together they are being called as register array. And the flag counters are being connected to the ALU in a bidirectional way. Then you have the instruction decoder and machine cycle decoding. The other parameter which plays a very important role is timing and control. Now, why timing and control? Because it contains the different control signals, status signals, DMA, and the reset signal, the clock signal and the generation signal. And then it is being connected to the power supply, which is plus 5 volt, and GND stands for ground. Then we have clock in, out, clock out, clock ready, read signal, write signal, ALE, status is S0, S1, hold acknowledgement, reset in and reset out. And this entire thing is being connected to the address bus. Now, address bus has been divided into 8 bits. As we are aware, whatever data you give to the 8085 processor, it performs in the form of bits. The bits can be converted in the form of 8 bits. Now, 8 bits, like from A raised to 0 to A15, we divide it into A raised to 0 to A raised to 7 address bus. Then second address bus will be starting from A raised to 8 to A raised to 15. Now, my question to you all is, if you have 20 bits, we are aware from A raised to 0 to A raised to 7 is one operation. One A raised to 8 to A raised to 15 is the second operation. If it is A raised to 20, then what? From A raised to 16, the processors will have A raised to 16, A raised to 17, A raised to 18, 19, 20, and the rest of the 3 bits will be 0. This is how the internal architecture of 8085 looks like. Now, here we have the 8085 pin diagram. So you should be aware of the pin, which pin goes out, which pin comes in. So you have the serial input pin which goes in and the serial pin which comes out. Then you have the reset signals. Then you have the trap signals. Similarly, you have hold and acknowledgement signal. So high order address bus, and then you have, which is unidirectional, and then you have multiplex address bus, which is going from one signal to the other signal, that is reset out and the clock out. Now, this is the pin configuration, the other diagram which shows the pin configuration. There are 8 address buses. Then you have the reset out pin. Then you have the different RST, that is reset pins, which have been connected. You have the X1 and X2 are the signals which are going on. You have hold acknowledgement signal and the hold data signal. Then you have clock signal. You have reset in pin. You have read signal, write signal, IO, and the different serial ports which are being connected to it. So you have a pin configuration and you have a functional pin diagram. The multiplex address bus, it is a bidirectional address bus which is connected to the 8085. And again, it requires plus 5 volt of connection, and it is being connected to the ground. That is for avoiding of the breakdowns with help of the power signals. Now, the thing what you should remember when you're designing an 8085 processor is that the total number of pins that are present in 8085 is 40 pin. So it is a 40 pin diagram. And it consists of 2 parts. You have the pin configuration and the functional pin diagram, and the different signals that are associated with the functional pin diagram. Now, what are the applications of microprocessor? Nowadays, our microprocessor-based systems are used in instruction, automatic testing, speed controller, traffic signals, light controller, and furnaces. Instrumentation. It is very useful in the field of instrumentation. because it has the frequency counter, function generators, frequency synthesizers, spectrum analysis, and many other instruments are available. When microprograms are used as controller, it is used in the medical instrumentation. Now, when it is used as control, microprocessor based controllers are available in home appliances. So, they are available in the case of your home appliances, such as your microwave control, washing machine control. It is used in controlling the parameters like speed, pressure, temperature, and which is used for the transduction. Now, when it comes to consumer, the microprocessors are used in toy entertainment equipment and home application for the entertaining in the form of your home theaters. In home appliances, it is used in powertrain, infotainment, door and seat, sunroof modules, climate control, security, and the dashboard.